Polya'S How to Solve It. George Polya was a great champion in the field of teaching effective problem-solving skills. He was born in Hungary in 1887, received his PhD at the University of Budapest, and was a professor at Stanford University among other universities. He wrote many mathematical papers along with 3 books, most famously, How to Solve It. Polya died at the age 98 in 1985. In 1945, Polya published the short book How to Solve It, which gave a 4-step method for solving mathematical problems. 1. First, you have to understand the problem. 2. After understanding, then make a plan. 3. Carry out the plan. 4. Look back on your work. How could it be better? This is all well and good, but how do you actually do these steps? Steps 1 and 2 are particularly mysterious. How do you make a plan? That is where you need some tools in your toolbox and some experience to draw upon. Much has been written since 1945 to explain these steps in more detail, but the truth is that they are more art than science. This is where math becomes a creative endeavor and where it becomes so much fun. We will articulate some useful problem-solving strategies, but no such list will ever be complete. This is really just a start to help you on your way. The best way to become a skilled problem solver is to learn the background material well, and then to solve a lot of problems. Mr. Jones has a total of 25 chickens and cows on his farm. How many of each does he have if altogether there are 76 feet? Step 1. Understanding the problem are given in the problem that there are 25 chickens and cows. Altogether there are 76 feet. Chickens have 2 feet and cows have 4 feet. We are trying to determine how many cows and how many chickens Mr. Jones has on his farm. Step 2. Make a plan. Make a table and look for a pattern. Procedure: make a table reflecting the data in the problem. If done in an orderly way, such a table will often reveal patterns, relationships that suggest how the problem can be solved. Step 3. Execute a plan. Step 4. Looking back, check 12 plus 13 equals 25 heads, 24 plus 52 equals 76 feet. We have found the solution to this problem. I could use this strategy when there are a limited number of possible answers and when 2 items are the same but they have one characteristic that is different. Break it up. Solve a simpler problem. If we wanted to break this problem down into simpler steps, we could first create a table to look for a pattern. 120 to 33 44 5. Now we have simplified problem into a table. The left-hand column is the step, the right-hand column is the number of cubes. Next, we look for a pattern. The number of cubes is 1 more than the step, therefore, we could say that step plus 1 is the number of cubes. Now it is manageable to figure out the 5th step, the 10th, the 20th, even the number of cubes on the 100th step. We just add 1. Step 5 equals 6. Step 10 equals 11. Step 20 equals 21. By simplifying the problem into a simpler problem, we could easily solve this one. Draw a picture. Guess and check. Amy and Judy sold 12 show tickets altogether. Amy sold 2 more tickets than Judy. How many tickets did each girl sell? You need to know that 12 tickets were sold in all. You also need to know you can guess and check to find 2 numbers with a sum of 12 and a difference of 2. If your first guess does not work, try 2 different numbers. First guess: Amy equals 8 tickets, Judy equals 4 tickets. Check 8 plus 4 equals 12. 8 minus 4 equals 4. Amy sold 4 more tickets. These numbers do not work. Second guess: Amy equals 7 tickets, Judy equals 5 tickets. Check 7 plus 5 equals 12. 7 minus 5 equals 2. Amy sold 2 more tickets. These numbers do work. Make a list. Judy is taking pictures of Jim, Karen, and Mike. She asks them, how many different ways could you 3 children stand in a line? You need to know that any of the students can be first, second, or third. You can make a list to help you find all the different ways. Choose one student to be first and another to be second. The last one will be third. When you make your list, you will notice that there are 2 ways for Jim to be first, 2 ways for Karen to be first, and 2 ways for Mike to be first. So, there are 6 ways that children could stand in line. Make a table. You save $3 on Monday. Each day after that you save twice as much as you saved the day before. If this pattern continues, how much would you save on Friday? You need to know that you save 3 on Monday. Then you need to know that you always save twice as much as you find the day before. You can make a table like the one below. List the amount of money you save each day. Remember to double the number each day. You save $48 on Friday. Act it out. There are 4 people in the room. If each one shakes hand with only another, how many handshakes occur? Students may act out the problem, or they may use counters, toys, or figures to act out the problem. They can also draw a picture showing what happened in the problem. Write a number sentence. Sam put 18 pencils in 3 equal groups. How many pencils are in each group? You need to know that there are 18 pencils and they are divided into 3 equal groups. You can write a number sentence that solve the problem. Write a division sentence to divide the pencils in 3 equal groups. 18 divided by 3 equals 6. There are 6 pencils in each group. Make model. Problem-solving model is a simple cycle used to solve the problems and challenges. The aim of the problem-solving model is to provide a simple, clear strategy for tackling problem-solving situations. Introducing this model will provide participants with an easy-to-use and transferable method of solving problems in any situation. Stage 1, identifying the problem. Stage 2, plan. Stage 3, do action. Speak louder than words. Stage 4, review. Stage 5, adapt. Word backwards. Jack walked from Santa Clara to Palo Alto. It took 1 hour 25 minutes to walk from Santa Clara to Los Altos. Then it took 25 minutes to walk from Los Altos to Palo Alto. He arrived in Palo Alto at 2:45 p.m. What time did he leave Santa Clara? You need to find what the time was when Jack left Santa Clara. You can work backwards from the time Jack reached Palo Alto. Subtract the time it took to walk from Los Altos to Palo Alto. Then subtract the need to find what the time was when Jack left Santa Clara. Start at 2:45. This is the time Jack reached Palo Alto. Subtract 25 minutes. This is the time it took to get from Los Altos to Palo Alto. Time is 2:20 p.m. Subtract 1 hour 25 minutes. This is the time it took to get from Santa Clara to Los Altos. Jack left Santa Clara at 12:55 p.m. Identify pattern. Jane has written a number pattern that begins with 1, 3, 6, 10, 15. If she continues this pattern, what are the next 4 numbers in her pattern? You need to find 4 numbers after 15. You can find a pattern. Look at the numbers. The new number depends upon the number before it. Look at the numbers in the pattern. 3 equals 1 plus the starting number is 1. Add 2 to make 3. 6 equals 3 plus 3 starting number is 3. Add 3 to make 6. 10 equals 6 plus 4 starting number is 6. Add 4 to make 10. 15 equals 10 plus 5 starting number is 10. Add 5 to make 15. New numbers will be 15 plus 6 equals 2,121 plus 7 equals 2,828 plus 8 equals 3,636 plus 9 equals 45.